Hi everyone, my name is Mark and I'm here with the Shell Stream program which is powered by NIHERST, and today we'll be looking at refraction. So some of you all may know refraction is the bending of light as it passes from one medium to another. A medium is anything light can pass through, such as air, water, glass, plastics and other materials. Once light can pass through it, it's a medium for light. Light refracts or bends as it passes from one medium to another because light actually slows down or speeds up as it passes through different media. Let me try and break it down for you. So consider you are walking on the beach, and yes, you're walking on sand, but you are walking through air, right? So as you're walking through air, it seems quite easy or effortless. But now you start to walk towards the water and you start to walk in the water. As you walk through the water, you realize that it becomes a bit more difficult to walk through the water than it is to walk through air. And that is because water is a different medium from air. And that's the same way light works as it travels. As light goes from air to water, it slows down and hence it refracts. We can see that as light travels through a less dense medium, it speeds up, and as it travels through a more dense medium, it slows down. So as it goes from one medium to another, it bends either towards the normal or away from the normal. From this, we can get Snell's law, which states that n1 sine theta 1 is equal to n2 sine theta 2, where n1 and n2 are the different media, and theta 1 and theta 2 are the different angles of refraction as it travels from one medium to another. I have a few experiments here to show you all how light refracts. First, I'll need a glass of water. I'll need a pencil. This is a simple experiment, but it's quite an easy way to show how refraction works. So I'll put the pencil in the water and let's see what happens. So I'll put the pencil, we can see it is one pencil, and look at what happens when the pencil goes into the water. What do you all see? Well, from looking at it, I can see that the pencil looks like it's broken, or there's a different piece of the pencil inside the water because it's not in line with the top part of the pencil, so it looks broken. But we all know that it is one straight pencil. Okay, I'll put it back. This happens because air and water are different media. When we look at the pencil, the top part of the pencil is in air, so light will be hitting the pencil at a different speed compared to the bottom of the pencil, which is in water. So as we look at the pencil, it looks broken because the light, as it moves from air to water, it refracts and the pencil looks broken. Now I'll use the same glass and I'll show you all how light refracts as it passes from air to water and then back to air again. So I have a note here and it's actually written back to front, but when you all see it through the glass, you're supposed to be able to read it properly. I don't know if you all can tell what this word is, but I'll pass it through the glass and then you'll be able to read it. So let's take a look. That word was refraction, right? If you didn't get it, that was refraction. So you could try this at home. It's a simple, easy experiment, but as you can see, the letters kind of in the opposite direction right now, but as I pass it through the back of the glass, it refracted and the letters were inverted, so you could see the word properly as refraction. Try this at home with different notes if you like, because it's kind of cool, you know, to write things backwards and then read it properly. So I have one more experiment for you all. Now I have a laser here and a prism, and we are going to see what happens when I shine the light from the laser through the prism. Before I turn on the laser, I just want to take off the lights and darken the room so you all could see the experiment a bit better. I'll put on the laser, and the laser is coming through here and it's actually hitting the top of the prism, okay? But it's hitting the top of the prism, and as the laser hits the prism, it actually refracts and the laser falls on the table down here. So it's not really up on my hand, as you all can see. There's some light coming through on top of my hand, but the majority of the laser beam is on the table, and that is because it refracts as it passes from air. It hits this prism, and this prism is a glass, and as it passes through the glass, it refracts and then falls on the table because it refracts as it comes out of the prism again. So I'm sure you all saw how the laser shone the light on the prism and the light refracted as it went into the prism, and it also refracted as it came out of the prism and back into the air. And that's how refraction works, guys. Remember, refraction is the bending of light as it passes from one medium to another, and we have derived Snell's law from refraction, which states that n1 sine theta 1 is equal to n2 sine theta 2. I hope you all enjoyed this video today, guys. Remember, try the experiments at home. It's some simple experiments. You don't need a fancy laser like mine. You can have a little pen laser. Okay, guys, and I'll see you all in the next video. Bye.
Hey guys, thank you so much for viewing, and thank you for joining the Shell Stream program powered by NIHERST. We have made all these courses available on the Ministry of Education's website, and you could find that at learn.moe.gov.tt. So head on across there and get those courses. You don't want to miss out. Also, please, we ask you to subscribe to our YouTube channel. Go hit that subscribe button, click the like button, click the notification button, so you could be updated with more educational and informative materials such as this one. And lastly, follow us on our social media platforms. That's Facebook, Twitter, and Instagram. Be part of the community, and let's do this thing together, and we'll see you next time.